Hey guys, welcome back to Engineering Made Simple. So I changed my channel name to Engineering Made Simple because I think it's more descriptive of what we talk about here. So anyways, jumping into what we're going to talk about today, I want to talk about basic OpAmp theory. So an OpAmp is a integrated circuit that you can use in circuits, and it has a large number of applications. It can be used in so many different ways. That's why it's so popular. So let's talk about what the schematic or the circuit symbol looks like for an op-amp. So an op-amp is a sideways triangle for the schematic symbol, and it's going to have an output, just as you would expect, VO. We're going to power the circuit chip or the circuit element with two power rails, or one positive and one negative supply. So we'll call that positive VCC and negative VCC. And I also have two inputs on an op-amp. So I have a positive input, also called a non-inverting input. And then I have a negative voltage input, also known as the inverting input. So I'm going to call these VP and VN for the positive voltage input and the negative voltage input. And this is pretty much it. This is what the integrated circuit looks like when you draw it for a circuit schematic. So what can we do with this? Well, first we should talk about the limits and the constraints on an op-amp. So before we talk about what it can do, let's talk about, what are the constraints. So I know a couple things about an op-amp that I can draw here. So the first thing I know about an op-amp is that the output can never be greater or less than the positive and negative supply voltages. So if I draw two tick marks on my graph, VCC and negative VCC, I know that whenever my output is trying to go greater than VCC, it's going to be clamped, or it's going to be saturated, meaning it will flatline at that value and it won't go any higher. Likewise, the same thing for negative VCC. Whenever I'm approaching my negative power rail here, it will actually flatline at this value and it won't go any more negative. So that's the first thing I know about an op-amp. So let me go ahead and jot down some notes as we talk. First thing is positive VCC and negative VCC saturation. The second thing I know about an op-amp is that the positive input voltage and the negative input voltage are actually always going to be driven to be equal to each other. So essentially, when you're solving a circuit using an op-amp, you can actually assume that Vn is equal to Vp. And the third thing that I know is that the input current going into the non-inverting terminal and the input current going into the inverting terminal are both going to be equal to 0. So if I draw my input currents here, IP and IN, I can declare that IN is equal to IP is equal to 0. The specific reason for why that is, if you're wondering, is the actual input impedance of these input terminals is extremely high. So whenever you have an extremely high input impedance or resistance, you essentially get an open circuit. And when you have an open circuit or near open circuit, you essentially have no current flowing. So that's the main reason why these are assumed to be 0. So the last thing we need to talk about with regards to basic op-amp theory are the modes of the op-amp. So there's two main modes of the op-amp, or two main regions. So the output has a linear relationship with the inputs. And when we're in this range and we're operating in this linear fashion, we actually are in what's known as the linear region. So I can actually call this my linear region. Whenever I get to an output voltage that is equal to or greater than my positive power rail, I saturate, meaning I cannot go any higher than that. I flatline at that value. This is what's known as positive saturation. And likewise, when I get to my negative, as we've talked about, I reach what's known as negative saturation. So with these two modes or three modes of an op-amp, I can basically theoretically predict what the output is going to be with regards to the input. Alright, well, that's about it for basic op-amp theory. Thank you for tuning in. If you liked this video and you thought it was helpful, like and subscribe. And make sure to catch our other videos on how to actually configure an op-amp for specific applications. Thank you.